Guys, Mr. Antonucci here, and in this example, we want to determine whether each of the following graphs, the functions, is even, odd, or neither, then determine whether it's symmetric with respect to the y-axis, the origin, or neither. So the first one is f of x equals x squared minus 5. So in this case, if we plug in negative x, so f of negative x is negative x squared minus 5, which equals x squared minus 5, that equals the original function. So since f of negative x equals f of x, the function is even, and since the graph is even, the function is even rather, the graph of f is symmetric with respect to the y-axis. Now let me just graph it real quick here in Desmos to show you f of x equals x squared minus 5, and you can see it's symmetric with respect to the y-axis, and it's also even. Okay, next function is 4x over x squared minus 5. So the domain is all real numbers not equal to plus or minus square root of 5. So we just figure that out so that we know that every number x is in its domain. Also, the opposite of x would be in its domain as well. So if we do g of negative x, that's going to be 4 times negative x over negative x squared minus 5, which gives you negative 4x over x squared minus 5, which you could think of that as negative 4x over x squared minus 5, which is really the opposite of the original function. So what we just proved was that g of negative x equals the opposite of g of x. So essentially, when you plug in the opposite x value, you get the opposite y value than you would have when you plugged in the positive x. So just to visually illustrate that, in other words, what we just proved is that the function is odd, so it's symmetric with respect to the origin. Okay, so g of x is equal to, if you just hit the fraction bar, it will, or the backslash bar, it will create a fraction. So 4x over x squared minus 5. And it's a little bit difficult to see here, but if you put a pin on the origin and spun it 180 degrees, the function would land on itself. So we say it's symmetric with respect to the origin. Okay. Part C, the domain of this function is all real numbers. So of course, for every number x in its domain, the opposite of x is also in its domain. So then we can evaluate h of negative x. So that would be the cube root of 5 times negative x cubed minus 1, which is the cube root of negative 5x cubed minus 1, which is the cube root of the opposite. You can factor that negative out inside. Okay. And then when you take the cube root of a negative number, the answer is negative. So you can think of it as negative cube root of 5x cubed plus 1. Oh, that should have been a plus right there. I forgot to put the plus. So this is neither the same as the original function or the complete opposite of the original function. So in other words, h of negative x is not equal to h of x, and h of negative x is not equal to the opposite of h of x. So the function is neither even nor odd, and the graph of h is not going to be symmetric with respect to the y-axis and not symmetric with respect to the origin. If we graph this, so h of x equals, if you type in CBRT, it gives you the cube root, so 5x to the third minus 1. You gotta zoom in a little bit here, and you could see that the graph is definitely not even, and if you put a pin at the origin, it would not land on itself in this case here. Okay. Part D, the domain of the absolute value function is all real numbers. So again, for every number x in its domain, the opposite of x is also in its domain. So let's just do f of negative x is going to be absolute value of negative x, which is really like the absolute value of negative 1 times x, which is the absolute value of negative 1 times the absolute value of x. The absolute value of 1 is 1, so it would just be absolute value of x, which is f of x. So what we just proved is that f of negative x equals f of x. Therefore, the function is even and the graph is symmetric to the y-axis. If we graph absolute value, so f of x equals absolute value of x. If you just type in ABS, it will create the absolute value function. Also, if you do a vertical bar like that, it'll give you the vertical or the absolute value function. So graphically, we can confirm that it is an even function. All right, and the last one, h of x, the domain is all x not equal to 5. So here's a quick trick. The number negative 5 is in the domain of h, but positive 5 is not in the domain. Here's where we're getting this. Okay, the denominator is going to be 0 when x equals 5. Okay, but a function can only be even or odd if for every x in the domain, negative x is also in the domain. Well, if positive 5 is not in the domain, and that's the only number that is excluded, x equals negative 5 is part of the domain, and the opposite of negative 5 is positive 5, but the function's undefined at positive 5. So it doesn't even pass the requirements for testing to see if the function is even or odd. So it's automatically neither. We don't even have to plug in the opposite of x. Okay, so this graph h is neither even nor odd, and the graph of h is not symmetric with respect to the y-axis or the origin. All right, guys, hope that one was helpful to you, and you take care.